All right, we're doing the 2012 released free response question number 6, part D from the Calculus AB exam. Part D, we've been working with this velocity function, v of t equals cosine of pi over 6. Part D asks us to find the position. So if we find the position, we need to integrate. And when we're integrating, we're going to need an initial condition. So they gave us this initial condition, x equals -2, and at t equals 0. So there's a couple of different ways to do this. I'm going to show you my favorite way to do it. That really comes down to the accumulation form of the fundamental theorem of calculus. This accumulation form of the second part of the fundamental theorem is just so useful that it's a good thing to have in your head at all times. F of b equals f of a plus the integral from a to b of f prime of t or x, whatever your independent variable is. We'll call it x for now. F prime of x dx. So what this says is, if I want to know a future value of the function, and all I know is a present value and the rate of change, then the future value of the function is equal to the present value of the function plus the integral over the interval of the rate of change. That's what that says. Now, if we're trying to get a position, well, we know that, that if the position is given by s of t, so if we have a position s of t, then velocity, which is v of t, is equal to s prime of t. So if I translate this into position and velocity, s of some time in the future, that's our position at some time in the future, is equal to our position at some known time, plus the integral from a to b of, since velocity is equal to s prime, so for our f prime, it's just the velocity function. So for our particular function, we're interested in finding the position at time t equals 4. So we're interested, so here's what we have. We have v of t equals cosine of pi over 6 t, and we're asked for v of 4. And they tell us that x equals -2 at time t equals 0. So we need to understand this as telling us that the position at time 0 is equal to -2. That's how we're going to read the x coordinate is -2 at time t equals 0. It means the position at time 0 is equal to -2. So now we know what our a and our b are to put up here, because t equals 0 is our a, and we've been asked not for v of 4, but for position at time 4. So we're asked for s of 4, and that 4 is our b. So we can now say that s of 4 is equal to s of 0 plus the integral from 0 to 4 of our velocity function, which is cosine of pi over 6t. And now we need a dt because we're doing an integral. So this way we're doing it as a definite integral. Another way to do it would be to take your velocity function and make an indefinite integral, and then use this initial position to find the value of c from the indefinite integral. But we'll do it as a definite integral. And I'm just going to switch pages so that we don't run out of room for that. So here's what we have now is s of 4 is equal to s of 0 plus the integral from 0 to 4 of cosine of pi over 6 t dt. Now we're going to solve this by doing a u substitution, because we have an inner function of pi over 6t. So we're going to say u equals pi over 6t, because that's our inner function. Du is equal to pi over 6 dt. And we just have dt here, so we're going to move the pi over 6 and make it 6 over pi du equals dt. Now that we have that substitution, we're ready to rewrite this integral. So we'll just bring everything down. S of 4 equals s of 0 plus the integral from 0 to 4 of, now we're going to do our substitution. So I'm going to say cosine of our pi over 6 we're replacing with u, and our dt we're replacing with 6 over pi du. So 6 over pi du. That's our substitution that we're making. Now we're ready to pull the 6 over pi out and do the integral. So our s of 4 is equal to s of 0 plus the integral from 0 to 4. And we can bring our 6 over pi out and call this integral of cosine u du. And I'm just going to keep bringing everything else down. And we know the integral of cosine u is sine of u. This is from 0 to 4. Now I have to replace my u equals pi over 6t. I have to put that back in there. So s of 4 equals s of 0 plus 6 over pi times the evaluation of sine of 6 over pi t from 0 to 4. So now I'm ready to really start evaluating this. I'll take advantage of the fact that I know that s of 0 equals negative 2. So for my s of 0, I'll put negative 2 plus 6 over pi. And now I'll plug in my 4 and plug in my 0. So we have sine of, I'm sorry, this is a pi over 6, isn't it? Pi over 6. Because our u is pi over 6 t. So we're going to have sine of pi over 6 times 4 minus sine of pi over 6 times 0. And we can leave our answer right there. That's where we'll leave it. We could, of course, go through and evaluate it, but we don't need to. Anything mathematically equivalent to the correct answer, as long as we don't have any variables left in there. So when we have the t, we have to plug that 4 in. But as long as we've now got it to where we have a mathematical expression with no variables in it, that's equivalent to the answer. So in the interest of saving time and not making additional mistakes, I'm going to stop right there, and that's my answer.